These are in listen-only mode.
Good morning or good afternoon, everyone. My name is Phil Liu with PNSQC, and welcome to our summer webinar series. And our first webinar this summer is with Clyneice Chaney. Clyneice is going to be talking about identifying and executing the most critical tests. So welcome, Clyneice. Thanks for being here.
Thank you.
Great. So before we get started, I'd just like to introduce our organization, PNSQC. We're in our 35th year, and we have an annual conference held in Portland, Oregon. And this year it's October 9th to 11th. It's a totally nonprofit organization run by volunteers like myself. And we tend to, and we love to have real practitioners come to the conference and really talk about their experiences. We have a really broad range of topics ranging everywhere from automation to DevOps, security, and a lot on mobile as well. Clyneice, can you move the...
Yes.
Okay. Okay, so before we get started, just a couple of house rules. So all the speakers, all the participants are muted other than speakers. And if you look on the right side on your GoToWebinar control, you can see that you'll be able to ask questions on the questions panel. So please feel free to put any questions you may have in there. Our webinar hashtag for Twitter is FindCriticalTests. And for all those that register for the webinar, you will also receive information on a recording and slides after the webinar. So we'll just keep going here.
Okay.
Okay, just a quick blurb on myself. My name is Phil Liu. I'm a board member of PNSQC and also a volunteer like all the other board members. I'm also the CEO of Exposoft, and we specialize in software quality and software testing. But today I'm here as with PNSQC, and I'm happy to introduce Clyneice. Clyneice, can you forward the... I met Clyneice, I guess about 6 or 7 years ago. Is that right, Clyneice? I think at a conference, and I attended one of your talks at, I think it was in Chicago. I can't remember, but I thought it was really interesting, and I've seen you a couple times since then at various events. I'll let you go ahead and introduce yourself.
Okay. As Phil mentioned, I've been in the business for about 30 years in terms of software testing, quality, organizational change, project management, process improvement. I am speaking at a couple of the conferences on a regular basis. I teach software testing classes, risk-based testing, and lean testing. And I also serve as a examiner in the broader quality area for one of the state Baldrige award criteria organizations. And again, I'm a team in my professional, a certified quality manager and a professional project manager. So I think that's enough of that. Let's go ahead and get started on the... Well, 30-something years give you a chance to do all kinds of things.
That's right. Thank you.
All right, so we're going to be talking today about finding and executing the most important or critical tests. And this is a webinar that was created or reduced from a full-day class. So what I attempted to do is on the screen you see all of the modules that are in the full-day class, and I will walk through each of the key topic areas. And by the end of the session, you will be acquainted with the techniques that you need to do in order to utilize the approach that we'll be talking about for finding the most important or critical tests. You won't have all of the knowledge to execute them all. The good news is that 3 of the techniques that I'll be talking about, there's extensive information about on the internet, so you will be able to go in and do some search and get a little bit more tutorial about how to do it. But the goal of the session is for you to walk away with understanding why you would do it. So we'll be talking about why we're going to be using a most important test focus, how you get started in initiating that focus or strategy, we'll be talking about coverage and coming up with the most important areas of your test, the application under test. And we're going to be talking about the most important test paths and data, and that's where the technique comes in. And at the end, we'll talk a little bit about how you pull all that together to execute and manage a most important test strategy. So when we think about software testing, we think about, in the end, for us as quality people, we know that testing is a quality control activity. So we're trying to control the quality so that the user experience is a much better experience. So we're trying to find the bugs before the customer does, again, to increase or control that quality and to provide an enhanced user experience. But we do know that testing isn't the best method for controlling quality. On the screen here, you see some data from Capers-Jones, and you see that there are other techniques that help us to also control quality. So we know that if an organization is doing formal design inspections, then they have a 45 to 68% defect detection rate. We know if you have a formal software testing organization, just the organization alone, and you're doing some basic formal testing, then you're in the 37 to 60% range for controlling or detecting software defects before they get to your customer. If you're not using any kind of formal methods at all, then you're in the 30 to 50% range. And if you have a formal quality assurance organization, then your defect detection range is somewhere between 32 and 55. So notice nothing got us in the 80%. Typically, it's the combination of these factors, like formal design plus a formal QA gets us in the 80% range. So I'm talking about this because we know that testing can't prove the absence of defects. It only proves that defects are there. And if you're doing effective testing, you find some of the defects that are there. So that we know that testing alone isn't cutting it. So we usually do those combinations that I talked about. But what we're trying to do here is that since we know that testing alone doesn't cut it, but testing is one of the most frequently used approaches for what? Detecting defects and controlling the quality. What can we do about increasing the capability of the testing that we're doing to actually find more defects? So that is the important point that we're trying to address in the techniques that we'll be talking about today. So on the screen next is that this is a figure that most of you have seen a couple of times, and you've heard about it, that we know that defects cluster. And so since we know that defects cluster, there's a tendency for that, they sort of not together. So, but looking at this diagram and the percentages is that 60% of the code could be defect-free, because typically we've got that 50% of the bugs are found in usually about 5% of the code in the more complex areas. So what this diagram suggests to us is that maybe some of the testing we're doing is testing, but is it effective testing? Because if it's not focused on the critical areas where you have the potential for finding bugs, then we've executed a lot of tests, but we haven't really advanced that quality control target, because a lot of the testing that we've done is in areas of the product where we didn't have defects anyway. And so again, the techniques that we're talking about today is to help us come up with a better strategy so that we are maximizing our testing in the areas where it is most likely to have bugs, and we're doing hopefully less testing. And I didn't say not any testing, but we're doing less testing and more strategic testing or lighter testing in those areas where the probability of defects, of finding defects, is lower. So how do we get to that whole process? One of the other things that we need to consider when we're talking about the most important or the most critical areas of the product is to understand quality expectations are different. We all know that people look at things different. They talk about beauty is in the eyes of the beholder, value is in the eyes of the beholder. And all that means is that each of us bring to any situation that we are viewing or participating in, our perspective, and that perspective then accounts for different opinions about it. So when they've done some surveys on what are customers' expectations in terms of software, there's some interesting data there. Today's consumers have, again, interesting and high expectations for quality. So we know that 39% of the customers feel that speed, how quick an application is often more important to them than the functionality. 47% expect a web page to load in 2 seconds or less. 40% will abandon a web page that takes over 3 seconds, and you'll just, go somewhere else. We know that low performance and unreliability of an application have adverse impacts to the business, and some places we had measured, and other places we haven't really measured it. And we know in this area of hacking that security and protection of private information is very, very important to both the customers and the business. So what is this slide talking to us about in terms of the most important test method? What we're trying to get is that one of the factors that you need to consider as you begin to look at your application under test is that the quality expectations of the ultimate end users need to be a factor that you are thinking about as you begin to evaluate that application under test, so that that is also a part of the criteria that will help you to decide or determine of the potential tasks that could be run, which ones are the most critical to do because they affect, one, maybe the quality expectations from the customer perspective, as well as they're the most complex areas of the code. So these are factors that we use that will help us to determine what those most important or critical areas are. So one of the things that we look at then is to do risk-based testing, and we want to look at what are the risks that are associated with quality. So if there are divergent expectations of quality, and testers need to know what those expectations are in order to ensure that they have adequacy in the testing, this becomes, again, a very critical concept for the most important test strategy that we're going to be introducing. So we need a systematic way. We don't want to just be like throwing the dice, but we need a systematic way to begin to know and to focus on testing the most important parts of the project. And so we know that, there are often last-minute changes that could affect, sort of like, waiting to see if the storm is actually going to show up. But what are we going to be able to do to be able to avoid potential storms or errors or problems or faults or failures in that software? So there are two factors that we're going to be looking at when we're thinking about associating risks that have the capability or the potential to impact the overall quality of the software. And again, these terms are not terms that you haven't heard of before, because most of us have heard about risk management in terms of software projects, but in terms of software, we're going to be looking at, in this methodology, this most important methodology, we're going to be looking at what's the probability or likelihood or chance that there are potential failures in that product, areas where you think that the product could fail, areas where there is a concern that the quality expectations of the customer may not be met in terms of performance, in terms of reliability, in terms of achieving basic functionality. So that probability of that risk occurring, that potential for failure, is one of the considerations that we need to evaluate as we begin to think about how are we going to identify the most important areas. So one of the most important areas would be those areas that are likely to have failures. So we want to assess our product for the probability that it could fail. Then the next thing that we want to look at, and again, this is not a new thought in risk. Any of you that have taken a risk management class have heard about evaluating the probability that a risk will occur. And what's the next factor? Evaluating the impact or damage or consequence. So here we're going to be focusing in on the business considerations. If the feature were to fail, if we had a security breach in this particular area of the software, what would be the impact or the damage or the consequence to our customer, and then also from a business perspective. So these two factors, how likely that you could have a failure in a particular area of the code, and the impact or damage or consequence that would occur should that failure occur. Those two things are what we use in project risk management, and they will also be a factor in helping us to come up with what are the most important or critical areas to test, because clearly those areas of the product that we've identified as having a high probability of failure with high consequence or impact or damage potential would be what? One of the most critical areas of the product that would need to be tested. So this most important test method is a method that's designed to help you answer some of the critical questions that you face when you're beginning to plan your testing strategy. So it helps you to understand or talk to the question, if we can't test everything, what must we test? And I would argue that today, for most of us as testers, that is something that we face every day in testing. As much as we love testing, and maybe some of us, not all of us, would test every day, all day, we can't. There are dates that a product has to be released. It has to go into production. And since we can't test everything, how do we systematically answer that question? And I would argue that the techniques that we're going to talk about are some of the techniques that you would use to help you to answer that question. If we can't test everything, what must we test? This technique that we'll be talking about today will also help you to get an idea on identifying what tests to run. So again, of the total number of tests that could be done, what order should they be done in, the most important ones, and how many of the tests should we actually execute. You will also be able to do some test planning management kinds of activities using this technique. It will give you some ways to track whether or not you're on schedule. It will give you some way to give some estimates of the effort of the project in terms of how big it is. And it will give you some idea about how to answer the question, how long could it take or should it take? And part of what you'll be doing is to think about what are the things that I know about the project, what are the assumptions that I'm going to make, are any of these assumptions, if they don't come true, would they be potential risks? So these are questions that are a part of the methodology that form that most important test methodology. So when we talk about the most important test process, what you see on the screen are the key steps to that process. And this is a process that is described in a book by Marnie Hutchinson. At the back of the slide, there is a reference to her book, and she does a very good job of walking you through. So again, this is a high-level overview of that approach. I've used it for a large number of years, and I found that, I've tweaked it and modified and adapted. I've used it on Agile projects. I've used it on waterfall projects. So the technique has flexibility in terms of how it's used. So let's walk through the key steps that we're going to be doing in the MITS process. So the first step is to talk about your assumptions. What are the assumptions that you're making about how the testing project will be executed? What assumptions do you have about the product? What are the constraints that are a part of that project? And what are the constraints that are related to the actual product? One of the things that I found that a lot of the assumptions in my early days of testing, I used to have this generic kind of set of assumptions. You assume that unit test is going to be done, and you assume that the code will be delivered on time, and you'll assume that the product will actually work when you begin to do your beginning the test. And so once I began to do and consider risk as a factor in the testing, then I had to ask myself, well, suppose that assumption doesn't come true. Is this now a risk that I need to plan for? So if it doesn't come on time, if they haven't done the unit testing, if it isn't functioning. You know, when I click on it, it begins to bomb. You know, what does that mean to my schedule and my project? So we do want to state some of our assumptions, and because we are going to be looking at the project from its risk perspective, we're asking you to evaluate what happens if any of those assumptions are true. Do they pose a potential risk to your project schedule, or do they pose a potential risk to the product under test in terms of causing certain features or functions or capability areas to have a higher potential for failing? Then the next step is you begin to build a test inventory. And this is one of the things that I really love about this, because it helps you to see how big the forest is. So this inventory, and we've got some slides coming up to talk about it, but this inventory is a list of all the potential tests that could be executed. And the approach that I take to it is that I do that from a test objective perspective. So if I've got user stories, I've got use cases, I've got requirements, regardless of my requirement input, even if I have just the application and no real formal documentation, I begin to then come up with what are the objectives that I'm trying to achieve, should this product be tested, and that begins to be my beginning inventory for that test. And I definitely will add to it as I go on. So step one, we're going to look at our assumptions and see if any of those assumptions are risks that could be considered. Then we'll begin to think about building an inventory. And if use cases, stories, whatever your level of requirements, that would be the beginning input into helping you to begin to build that test inventory. And then the third step, you do what they call mix analysis, and I call risk analysis. So that's where we look at the product under test, we look at the potential areas that we have the inventory, and we begin to ask those risk-based questions. What if the security area were to fail? What is the likelihood that we could have problems in the integration of the back end with the front end? So this analysis allows you to identify, again, the probability that the software could fail. And once you determine that there is a likelihood or chance or probability that that feature or module could fail in a certain circumstance, then you ask yourself in analysis, if it were to fail, how bad, what's the damage, what's the impact? And those two numbers, if you've got a high probability of failure and a high impact, then you've got what? An item that's in your inventory at the very high list of this is a critical area that I need to consider testing. So if you go through your inventory and you're looking at it from that perspective, you end up with then a ranking of the areas of your tasks, your objectives, that allow you to begin to start looking at groupings of test inventory or groupings of features and functionality from a most critical to moderately critical to less critical, and to help you to make those decisions about the most important areas of that product that should undergo testing. So then step number 4 is using that information, you can begin to do a rough estimate of your test effort. So again, I won't go into details for that. That's a basic functionality. I think most of you probably fairly comfortable with estimating your effort. Then you take a look at if you've got an idea for how big the effort is, and you've got an idea of what's in your inventory, then you can begin to take a look at what kind of resources do I need. And I know a lot of times we don't get to negotiate resources. The resources are the resources that you have. But there are some cases where you might be able to potentially get additional resources depending on how that effort is going to shape out and what your analysis tells you in terms of the areas that are more complex or more critical or more important to test. Then the step 6 is build the test. And when I say build the test, I'm also talking about designing the test. So here we're looking at our inventory, and we've got it prioritized based on our analysis from a risk perspective. So now we begin to design what are the actual tests that I need to execute and conduct in order to achieve these objectives that are then tied to risk. So then now I've got a whole strategy based on the most important tests based on a product failure risk analysis of my object under test. Then the last one is you conduct your test, and then naturally you're going to collect some data about how that performance went, and that allows you to, again, potentially improve. So from the perspective of the webinar today, we're going to be talking a little bit more about the myths analysis and also about the inventory, because those are the two elements that are potentially new for you in terms of what you're doing currently in testing right now. So how do you begin to plan a successful test effort? And this is an interesting riddle, and since it's not a live class and you can't really raise your hand and answer, I'll pose the question, let you think about it, and then I'll talk about it. So the riddle is it possible for test coverage to be sufficient, but for the test effort not to be? So just take a few minutes to think about it. So again, is it possible that as a tester, you have actually planned for sufficient coverage, but does that mean that because you've got adequate coverage that you've got an adequate test effort? And I know you're thinking, yeah, she's got a trick question, because obviously the answer probably needs to be no. And you're right. And the reason that it is possible for your test coverage to be sufficient, but the effort, that's the overall testing project, not to be, because if your coverage is not sufficient in terms of maybe you've covered all of the requirements and you've got 100% requirement coverage, but if you don't have a test strategy that also includes some critical tests or important tests, or those areas that have a higher probability of failure, then you satisfied all of the requirements, but there's a potential that the testing effort would not be sufficient to identify what? Those customer expectation kind of defects that often require a more, not just a requirement-based approach to testing, but a more stringent approach to identifying those tests that actually cause the software to fail. So the short answer is yes, you can have adequate test coverage, but the effort cannot be sufficient. And what we're trying to do with the most important test effort is to give you both, to ensure that the coverage that you have is adequate, as well as the effort that you put into the testing is sufficient also. So one of the decisions that you'll be making for testing is if you've got an inventory. Remember back in step 2, we had an inventory of potential test objectives. So let's say you have an inventory of 200 potential objectives. So that is what is available to test. But then the next question of the inventory items that you have available, how many of them should you test? And the decision on what you should test from what is available should be based on that risk analysis that I talked about. So you should be identifying of the available test objectives based on the ones that are high probability of failure compared to high impact for potential damage or harm, or so that formula is what gives you the ones that should. But oftentimes in testing, we do know that just because we have a schedule and we have a plan, we often don't get to do what? Everything that we plan. So the third point in our decision is we have an inventory of test objectives that are available. We've identified using our risk-based approach what we should test. Then sometimes we end up with what we can test. So what we like to do in this particular approach is to identify what we can test ahead of time. So if you run short of time, which we almost always do, that you have identified those that that should be tested and that you can test, and you know which those are. And so it allows you to strategize better in terms of planning your tests, and it allows for what? The test effort to be a stronger effort, so that not only have you looked at coverage, but you've also identified what should be tested, and you've identified early what you can test based on the current schedule that you have in place and the plan that you're trying to execute.
So, Clyneice,
So,
I have a question
yeah.
for you. How do you assess your
Mhm.
available tests and the quality of your available tests? I mean, that seems like a pretty arduous task. It seems like the basis of the beginning of that thought process also.
What I do is I began to look at the product, and I like to do it in terms of a walkthrough with the development team, but if that's not possible and you're in an environment where the testers actually have business knowledge of the system, I do like a walkthrough of the plan application under test. And so we walk through it and we're asking questions like, what could go wrong here? Could we have a failure here? What's the likelihood that something bad could occur here? And so I target areas of the product very early as areas of high probability for potential damage. And so then I create just an objective. So I don't really have a test in that inventory. I just have a test objective that would say things like validate that the interface between front end and back end is working appropriately, or validate that the requirements and the middleware are all executing properly. So the inventory is at a fairly high level at that point. And so what we're doing in the analysis is that we are looking to see whether or not we are structuring an inventory item. Well, let me back up. We want two things out of our inventory item. We are looking at if you have to do testing for requirement-based coverage. So I like to identify those tests that I have this test because I'm validating that a basic requirement is being met. And then I have these other tests that I have in there, and these are designed to actually break the system or challenge the system so that if there is a potential for a failure to occur, that this test has a high probability of doing that. And for me, the basic requirement tests are they're simple, they're straightforward, but typically we find that that's not the area of bugs that find their way into production. It's those more challenging ones. So what we're doing in the analysis is evaluating not the requirement-based ones, but those test objectives that you have that are designed to stress the system. So is that a shorter list for you from that perspective?
I think so. Still long though, but go ahead.
Still long? Okay. If we were to then take the objectives in each objective, we evaluate what's the probability of failure and impact, and we had a score.
Yeah.
I've done this, yeah, then we could rank on the score. Typically what I do is I assign a score of 1 to 5 for probability of error happening, and a score of 1 to 5 for impact or damage. And so the highest score in my matrix would be 25.
Okay.
And so then I sort of chunk it up so that the bottom of the 25, like 1 to 10, are low. And then let's say 12 to 18 are moderate, and then 18 and above to 25 are the high. And that allows me to then begin to come up with a strategy for each of the different groups that increases the coverage, but we want a combination of complex as well as requirement-based, especially if you're required to do that. Does that make sense?
Yeah, sure.
Okay. So part of what we want to do in this inventory is to make sure that you're considering all the possible kinds of tests that could be done. So we have tests that are associated with the path. So if you've got multiple paths throughout the system, then how many of the paths are going to be covered by the test in your inventory? Then we have, if you've got a large scale system, you could have multiple modules. So what's your strategy for assuring that the integration of the different modules is comprehensive in terms of coverage and in terms of the right kind of test to stress whether or not there's a high probability of failure. Then there's tests associated with the data. There's the tests associated with checking end-to-end functional tests. And again, this is not a total list of all the kinds of tests that we can do, because we know now with mobile testing and web testing, we have hundreds of different kinds of tests that can be done. It's an example of part of what you're trying to do in the inventory is to look at functional testing, look at your scenarios, look at your configuration requirements, look at potential regression requirements, and your inventory should be composed of potential tests that meet all of the kinds of potential areas that are touched on by your application. So this is a web application, then configuration would have potential, number of browsers. If it's a mobile application, then you've got the configuration associated with the different devices and different operating systems that will be supported. So what we're trying to get at the inventory is we want a complete inventory, and the assumption is that this is going to help you to figure out of all these inventory items, which ones absolutely should be tested, and then looking at your schedule, which ones of the should can actually be done in the time frame that we have. And so I think most of us do some of that now. We just don't do it as structured or formally, and we don't have as much data if we can use the spreadsheet that I'll be sharing with you. And that's in terms of how to get this done. Any other questions before I move on? Okay, so this inventory provides, again, the opportunity for you to begin to prioritize the list of test objectives that need to be done. And I'll be honest with you, sometimes I don't have test objectives. I put high-level user stories in this inventory. I put high-level use cases. So depending on what you have to start your inventory, you can be very flexible about this. But you have the inventory of items, and then you use the risk analysis of probability of failure and impact to begin that prioritization process. And again, you're going to be focusing in on those areas that are most important, because that will help you to come up with the effort and schedule. Because in the end, if you run out of time in testing, you clearly want to have run out of time after you have executed all the critical tests that need to be done. We don't want to have them dangling and say, we haven't got to that yet. So it's the basis for coming up with your test coverage data. It's the basis for helping you to come up with what's your contract on the strategy, because the inventory and the prioritization are the discussions that you have about what's important with the project team. For instance, I was on a project last year where I asked the project manager, what is it that you're concerned about in this project? And this was a very well executed Agile project. And so they were doing continuous integration. They were doing very strong automated testing. And so I was brought in as a test strategist at the end. And so I looked and said, well, gosh, they're doing all the right things you're supposed to be doing in Agile. My question to myself was, do they really need a tester? And so then I said, well, if I'm not sure that they need a tester on it, if I were to test, what would the value be? So I talked to the project leader and I said, what is your concern? And he had two concerns: that the project would fail its evaluated measures, so that it would fail a measure that should have passed, and that it would pass a measure that it should have failed. So I had a huge inventory of like 200 plus user stories that could have been tested. And that was in my base inventory. But at the priority of that inventory were all of the test objectives and user stories associated with measurement testing. And so in the end, we did extensive coverage of the measurement testing test objectives. And we had a test strategy that was very, very light for all of the other user story items that were in the inventory. And so that's what we're talking about in terms of that. And this was a 200 plus inventory. Again, it was a small Agile project. So that's what we're looking at in terms of how to use that index. The risk analysis is driving it. And again, it's based on probability and severity of potential failures in that product. And it helps you to think through the test process, because by the time I did the inventory and talked to him, I had a high-level strategy in my mind that was very easy to document. And we ended up with like a one-page strategy that the project team looked at, and they evaluated and said, if you test to this strategy, we're comfortable that you will have, one, added value to the project, and that these are areas that are outside of the scope of the testing that they were doing as the Agile testers and developers on that project. So before I go on, any questions about the inventory and the risk analysis part of it, how it's driven?
Not so far.
All right. Okay, so on the screen is a spreadsheet. And I do have it available, and Phil, that's what I was talking about when we had the audio problem is I can email it to you. So when you make the slides available for download, they can also download this spreadsheet. But what the spreadsheet is, it allows you to begin to build the inventory. And so column 2 on the screen here is the inventory item. And, you know, column 1 has different information. So they were tracking in this particular example, features that were related to bug fix information. They had new tests, they had existing application tests. That column is for your information in terms of how you would want to use it. The critical item you want to have is column 2 is the inventory. And so then the third column, this is the total number of tests that have been identified. So this is where you begin to do your objectives. So they've got the total number of tests. And then there's formulas in the spreadsheet. So using, again, that risk analysis we talked about, it comes up with an average ranking. And so that ranking allows the inventory item to be prioritized. And then you begin to do an estimate, how much of these tests are you going to cover in terms of your coverage. And again, there's some calculations in it. It's expecting you to do coverage, higher coverage for what? High risk items. And lower coverage for what? Low risk items. So everything is driven from the risk analysis. So how accurate your risk analysis is will drive the accuracy of this. And the first time I did it, my risk analysis was a little shaky. And so I fine-tuned it and got better at it. And I found that this was a good way to predict how much I should test and what tests and what areas in terms of a more quantifiable approach. And like this column here, past performance, is where you would track how many you actually covered and used the last time, so you can compare if you're retesting an application with an updated version that allows you to compare what you estimated the last time with your past performance, and again, be able to track and improve the tool. And then, so over here, the last column, again, is that ranking number that we talked about. And this is the bottom half of the spreadsheet. I couldn't show the whole thing. So you can see here, there is a formula that calculates the total number of all the tests. And then there's a formula that calculates what's the minimum percentage of test coverage that needs to be done based on this total number of tests. And then, so that was 64 out of the 200 tests. And then there is a proposed test coverage. And again, you can play around with the percentages. If you're in a high risk area where this application has to have very high quality standards, then you would up the percentage that you would use. And maybe you want a much, 75, 85, 90% coverage. If it's a application where failures in this are result in really, really, really bad consequences. So you can play around with the formula. So the spreadsheet is very straightforward and easy to use. You can see the formulas in them. But when you're done with the inventory and your risk analysis, you will have these 3 values, and that will give you an indicator of the question we had before. This is an inventory of everything that is available, and it will give you an indicator of what you should test, and then it gives you an indicator of what you can test. And depending on your time and schedule, you can play among those 3 sets of inventory items for your testing effort. Any questions?
I was just wondering, it seems like,
Mm-hmm.
it seems like this would get to be really a huge spreadsheet for a big application. Do people actually
It
use
could.
it for really
Mm-hmm.
for big apps, or is this more for smaller type things?
I've used it for, I'd say, moderate size applications. What I've been playing around with is to use it in like Quality Center with some of the fields that you add in, and so I'm playing around with that, but you're right. It is probably better for a moderate-sized project, unless you're able to use it from a module perspective.
Oh, okay.
In a system endeavor,
Right.
you know,
You
chunk
could
it up so you have one spreadsheet. Go ahead.
That makes sense. So you would
But
break
yeah.
up one spreadsheet for a module or one spreadsheet for an area of
Mhm.
testing that you wanted to determine what your
Right.
nits
Right.
were for those particular sections. Yeah, that makes
Yeah.
sense.
Okay. And again, I think once you play around with using it, you can see there are some projects where having this would be very helpful, and maybe there are other projects where you don't have to do it to this degree of formality. For instance, like the Agile one I talked about, I had the inventory and I did the risk analysis on it, and I didn't do the rest of the projection because I did the strategy based on the project leader was concerned about those 2 risk areas, and so I came up with a strategy based on the risk analysis and the inventory, and I didn't use the rest of it. So I think there's potential for you to use it. There's flexibility in how you would use it depending on your needs. But if you're struggling with, I'm not really clear that I have a handle on how much testing I need to do, it gives you a good start on figuring that out.
Okay, thanks.
Okay, all right. So that's the inventory. Once you figured out the number of tests that you are going to do, then you have to design and actually write the test. And again, we're looking at techniques that help you to get the smallest subset of tests that have the biggest bang. So the techniques that we're coming up to talk about are old techniques. They've been used for years in testing, but what I find is that a lot of us, I didn't find out about these. I've been testing for about 8 or 9 years before I ran into these techniques. So some of you've seen these before, others of you may not have, but again, I'm talking for the concept of you understanding how it could be used to further reduce or get to that best number of tests, but we can't get into how to do it all in 1 hour. So one of the things that we want to talk about is paths. One of the best ways to come up with the total inventory of tests needs to be done is to know how many paths there are through the system or the module. And so those paths allow you to get some sense for the breadth and scope of the testing that needs to be done. So it's a good way to give you an estimate of the overall testing effort. It's good to give you a sense for how the business might actually execute or individual users might actually execute that particular system. If you're looking at the maps of menus, you've got a GUI-based system and there are maps of menus. Again, that gives you a sense of how much testing effort needs to be done if you look at each menu and the complexity of the menu and the interactions that are occurring within it. You can use logic flow maps. Use cases, again, provide a way of quickly identifying the different paths or scenarios in a module. And there's very formal path analysis tools out there. Also, a sound foundation to support minimal testing. But what we're trying to get at is that if you've got a handle, again, on the total scope, then you want to then use some additional analysis to get that scope down. So one of the things we want to do is talk about using path analysis. You can use use cases or user stories. I use those synonymously here, or menus. And so, and basically what you do is you just count the menus. And again, I do a risk analysis in terms of the menus that I have, which ones are complex, which ones have a lot of back-end algorithms. And so those menus then become a way for you to have an inventory item in your test inventory, and then you look at the complexity and the degree of probability of failures occurring in some of the interactions in that associated with that menu and the code with it, and you can come up with your probability of failure as well as the potential impact. And that again allows you from the menus to get the scope of the inventory items and then begin to do risk analysis. You can do the same thing with your use cases, the high level use cases that show the basic functionality, not the technical ones so much, but the scenario based ones. So use cases or user stories, again, are a way to count and give you the starting point for your inventory item that you're going to do the risk analysis on. The next thing we want to talk about, again, in terms of techniques that help you to get to the minimum set of tests that need to be executed, is to look at BVA, look at decision tables, and look at equivalence partitions. And we're not really going to get into state transition because I couldn't get it all in the time frame here. So let's talk about these as techniques. So for equivalence partition, this is a technique that, again, if you've got lots of potential data inputs and you don't want to test, or you shouldn't, or you don't need to test all of them, then what is the set that you need to test? So again, we're trying to down select from a larger list to a smaller list. So this is a technique that allows you to, let me back up a little bit before I get to the scenario that we have on the screen. So it allows you to divide up the input data in a partition in such a way that you can say that this set of numbers or this input values are equivalent to this set of input values. So therefore, I only need to test one out of the set. So look at the problem we have on the screen. So there's a customer. They're eligible for a discount if they're at least 18, but no older than 56. So using the equivalence partition technique, we were able to come up with 3 sets of potential input value ranges. So any number less than 18 would be a negative testing value. So using equivalence partition, we should be able to pick any number from 1 to 17, and even actually a negative number also. And that should do what? Give you an invalid test item for that particular input value, so that the scenario would not be true if you use a number less than 18. But again, instead of testing every number from 1 to 18, you pick one, and that 7 or that 6 that you select is equivalent to the 0, the 1, the 2, the 3, the 4. The same thing with if they can't be older than 56. So we know that 57 through 2000 or 3000 or et cetera are all valid, in that they all should be labeled as not available for a discount. So again, if you're using the equivalence partition concept, then any number post 56 would be equivalent to 57. And so you can then again have one set of numbers that are used rather than doing lots of input values of testing numbers greater than 58. And then the valid numbers are between 18 and 56. And again, using equivalence partition, the concept is that all of these numbers are equivalent. So 19 is equivalent to 20, is equivalent to 21, which is equivalent to 41. So you pick one. So using this technique, you have reduced the number of tests that you're using to test the input values of a particular field substantially, based on the potential numbers that could have been done before you use the equivalence partition. So the next thing we want to talk about is boundary value analysis. So this is another technique, and again, it's often combined with equivalence partition. This one says that we have found that most of the errors in terms of input values occur around the boundary. So if we go back to our screen, we had boundaries at what, 18, and we had a boundary at 56. So using boundary value analysis, it refines your equivalence partition so that it's saying that you typically try to get within your boundary one value that's inside the boundary, one that's outside the boundary. We want to get the minimum value, and we want to get the maximum value, and then you want to do some that like negative numbers, or that's not a number that would potentially cause errors. And so using this technique again, if you've got thousands of potential input variations, we found that boundary value analysis combined with equivalence partition give you the capability to substantially reduce the number of tasks that you have associated with testing data input fields. So what it would look like here is that if we added boundary value analysis to our equivalence partition, we've got that we would be creating a test that had 17 18, and 19, because those are what inside the boundary and outside, and then we would test 55, 56, and 57. So again, a technique that will give you a reduced set of inventory items potentially when you're doing data validation and or input validation type testing. I'm going to pause here to see if there are any questions before we go on, and we are coming close to the time. I can feel myself talking faster.
No, I see you have a low
one
battery. You have a low battery too, so we better get going.
Oh, I need to, oh, yes, I'll go plug in.
Okay.
But in terms of how low is it? Okay, should I go get my plug in? I can talk while I do that. But the third technique we're going to talk a little bit about is using decision tables. And again, decision tables are a technique when you have different combinations of inputs that need to be done. So you've got different rules. And so again, decision tables allow you to come up with the minimal set of tests that need to be executed. And the time frame we have is definitely too short a time frame for us to really talk about how to do this. But this technique for software testing is very well documented on the internet, so you will be able to get even tutorials that will walk you through. But basically, it's a way of systematically combining the complex business rules. So for instance, in the application I talked about, we had several rules that we needed to evaluate for the different measures. So for a C1 test, there were these rules that had to apply. And for a C3 test, we had a different one. So we ended up creating a decision table that allowed us to get just the way that we could execute the largest number of rules and the smallest number of tests. So that is what the decision table allows you to do. And I think I have an example of it. I do. So this is an example of what the decision table would look like for the different conditions. So on the left side are the conditions or input, and then you've got different rules. And so it allows you to then come up with test scenarios for the different rules so that you can assure yourself that every categorization of rule has been tested by this subset of 5, 6, or 7 tests that exercise all of the rules and all of the combinations that could apply. Any questions?
I don't think so, not right now. I think we have a couple more minutes, then we're about done.
All right, we're at my summary slide. So basically, let's review. So when we talk about the most important test concepts, the takeaways that I'd like you to take away is one, is that you want to begin with an inventory. And this could be an inventory of use cases or requirements or user stories or test objectives. And that inventory should be as extensive as possible to reflect the total scope of what the testing effort is. And then you take that inventory and you do a risk analysis on these items, which are most likely to fail. And if they fail, how bad could the failure be? And with a score that allows you to rank in terms of low, medium, or high, risk and priority. And then to further refine that using the spreadsheet that will be shared, you can plug in your numbers, come up with how many tests. For this test objective, I got 20 tests. For this test objective, I decided we can do it in 5 tests. So you go through for each inventory item, determine how many tests you think you need to do to execute that particular inventory item. And the spreadsheet will then calculate and give you 3 key values. The total number of tests that you've identified for this area, the total number of tests that should be tested, and then the minimum number of tests that can be tested in the scope of whatever time frame that you have. But basically that minimum number is that you shouldn't fall lower than this number of tests if you want to have what? Adequate test coverage and adequate test effort. So last point is that to further reduce your inventory, if you use these techniques about path analysis and data analysis, it will allow you to further reduce the number of potential tests that get done, so that in the end, you've got the smallest subset of tests possible for adequate coverage and adequate test effort.
Great.
And I think that's it.
Yeah, thanks, Clyneice. You had mentioned a book that had a lot more details on that. Could you give that to me so that I
Mm-hmm.
could possibly, I'll send it out to the whole group to make sure
Yes.
that they have access
Here,
to that. Oh, there it is. Okay.
okay, it is. It's the Software Testing Fundamentals by Marnie Hutchison,
Uh-huh. Wow, this
Wiley
is great.
Publishing Company. Yes,
Okay.
yeah, 2003.
Oh, that's perfect. Just a reminder to everyone that, you guys are going to get a copy of these slides, so no need to copy stuff down here, but that's great. Um, can you go on to the next slide? I think we're just finishing up, and
Yes,
thanks for joining us today, Clyneice. Can you go to the next slide?
I did.
Okay, great.
This one?
Yeah. Uh-huh. And so we're looking forward to your invited talk, Trimming Down Your QA Effort. I guess everybody's trying to do more with less, right? So that's definitely going to be a hot topic. What about, you also have a workshop. What is your workshop on?
One is on agile testing. How
Mhm.
lean can it be?
Mhm.
And there's another one that I'm trying to remember. Real quick.
That's okay. That's all
I didn't
right.
know you were going to ask me
No,
this.
that's a trick question. That's a trick question. Sorry about that. You're supposed to say yes and no, but that's okay. Um,
But yeah, I have 3 topics. So the invited talk
okay.
and 2
I
workshops.
know. Okay. So we look forward to see you in October, and I hope that those that are listening today are able to come to the conference and see you as well, Clyneice. It's been great having you, and thanks very much.
Thank you. I love talking about testing. I guess you can probably tell. I get really excited about it.
You did. Thanks a lot, and we'll see you in October.
All right then. Bye-bye.
Okay, bye.